guys, once again. Hope you find you well, chemical engineers. Once again, this is Tunat the Terror from NAST, Chemical Engineering Part 3, undergraduate. Right. So, when we were Part 2, we did gas absorption, whatever, from mass transfer 1B, right? So, these are the formulas which we use to solve the gas absorption problems, right? So we find X and Y, then we find capital letter X, which is the mole ratio, and then the mole ratio in the liquid, the mole ratio in the gas. This was a tedious thing to do. I never did it in any one of my problems. So then you might ask, how did you do it? What I did initially was like, okay, so I have to find out the X, right, and maybe postulate my X values and postulate my Y values, then change these. Then for me to find the mole ratio, I have to say X over 1 minus X, then calculate using another X. Say, it was tedious for me. Then doing that, I think you will never finish the exam paper. So what I did instead was to unite these small formulas, these things to get directly. And what we need to do is to find our mole ratios and our mole ratio in the liquid, mole ratio in the gaseous phases. So we only need these two columns, so we don't need to do this, right? So now, but there's no formula relating this to this one. So that is what I discovered. I formulated a formula which relates mole ratio in the liquid and the mole ratio in the gaseous phase. Please be along with me. I don't need you to be able to derive this. I know you are mathematicians, you can also do it, but the most important thing is to know the formula and to claim it, right? So let's go into it directly. So we've got these things, right? So how do we unite them? That's the first question which came into my mind, right? So okay, let's start from here. So we need just to have maybe two equations, right? One is X, upper X is the subject of the formula, then the other one is the upper Y is the subject of the formula. So let's go, right? So we know that upper X is equals to small x over 1 minus X, right? That is how you know. So instead of doing this, you can take your X from there, which is partial pressure of FA, partial pressure of X of A over vapor pressure, right? So it just needs to say partial pressure, so pressure of A over vapor pressure. So you'll be given the vapor pressure and stuff, right? So if you have any problem, maybe you just post a problem of gas absorption, which is a simple one, and I'll just do it for you, right? So divided by what? By 1 minus partial pressure over vapor pressure, right? Then let's solve this. So we know we've got PA over V, vapor pressure over vapor pressure, divided by vapor pressure minus partial pressure over vapor pressure, right? Now, to simplify, let's just do this. Vapor pressure, partial pressure over vapor pressure multiplied by vapor pressure over vapor pressure minus partial pressure. Then these cancel out. Then you remain with what? PA is equal to vapor pressure over partial pressure of A. Right. This is where we are right now. Then the question is, what next? So you notice that in your questions, you're not given the partial pressure of A, because the partial pressure is proportional to the x magnitude, right? So we're not given this. So let's eliminate the partial pressure, so that maybe we might include the total pressure, because the total pressure is given the vapor pressure and the total pressure. So let's try to make the formula contain the vapor pressure, right? So now what do we do? Let's use our Y component. So we know that our Y is equals to partial pressure over what? PT. So let's eliminate the partial pressure. So if we eliminate partial pressure, we now have partial pressure is equals to Y total pressure, right? So let's just plug it into our equation. X is equals to what's our partial pressure? It's y pt over vapor pressure minus y pt. Hopefully we're still going together. So now what's next? Let's eliminate the y, because we don't want to have the y, we want to have the capital letter Y. So what's the relationship between the y and the capital letter Y? Right, so we know from our formula here that y is equals to y small over 1 minus, sorry, it should be y here, over 1 minus y. Alright, fine. So we said y is equals to y small over 1 minus y small. Right, so let's substitute it here. We have x is equals to capital letter Y divided by 1 minus, oh sorry, application here. And let's first make y substitute the formula, right? So what, how do we make y substitute the formula? Okay, fine, let's just say 1 minus y multiplied by y is equals to y, right? Open your brackets, y is equals to y, then you say y plus y, capital Y is equals to y, then factor out y, then you say y plus is equals to y, then our y becomes capital letter Y plus this, okay? So now in place of our y we put this, right? Let's go to this formula, then plug that. So now x is equals to y over y plus this, right? We multiply this by total pressure, which is PT, then we say divided by, right? Because here we don't want to say over, because it would be boring and clumsy. Okay, vapor pressure minus, in place of y we say capital Y over 1 plus y, then all this is multiplied by what? PT again. So I'm now seeing it's going to be making sense. Alright, what do we do then? Okay, let's rearrange these. Okay, y pt over 1 plus y, sorry, let's hope it's not too clumsy, divided by, let's make this common denominator y plus 1 plus y. So here PV denominator is 1, because so it's just say 1 is 1, so 1 into this, it gives us PV times 1 plus y. Hope it's clear. Then here into this we have just our y pt, right? So now we invert. So when we invert, what do we get? We say y pt over 1 plus y multiplied by 1 plus y over PV 1 plus y minus y pt. So now we now see we don't have any partial what, right? So we cancel out the 1, right? Then now after we've done that, we are left with, let me write on the other fresh, right? So we cancel it out, we're left with x is equals to y pt vapor pressure 1 plus y minus p ty. Okay, fine, we're done. So this is our equation in terms of what? In terms of x, right? So we usually start with this equation. We can use this equation, right? How do we use this equation? Okay, let me tell you. Let's say you've got a range of y which you want to, because your graph will be like this, and so you know that the maximum value of y which you want here maybe is 0.002. So now you just plug 0.002 here, and you know the PT, the total pressure will be given, the vapor pressure will be given. So you now plug all your things, then you get your value of x. So when you get your value of x, now what you do is this: you plot your graph, right, and your number of values, your type of values. Then you put you now know your maximum x. Let's say whatever the value, 0.2, right? So now you break down your values so that your scale fits perfectly. Then after you break down your values, then now there's this equation which I also derived, which gives us, which makes y the subject of the formula, right? But now you don't need to derive it from the start. You can simply manipulate this one so that you get y subject to the formula, because it will be tedious to start from the start again, right? So let's just manipulate that one. Let's say x, and let's multiply it with the denominator, which is this one, right? So let's multiply with the denominator so that we break it and make y subject to the formula. Vapor pressure 1 plus y minus total pressure y is equal to what? Y pt. Sorry, I was writing here, right? Open up the bracket, x, okay, fine, pv plus pvy minus pty is equal to y pt, right? X pv plus x pvy minus x pty is equal to y pt. Let's take y to the right side, so we now have y pt minus x pvy, so yeah, it's minus, because then plus x pty is equal to x pv, right? Factor out y, you have pt minus x pv plus x pt x pv, right? So now y becomes x pv over pt minus x pv plus x pt. Now this is the formula. You can choose to make, you can actually do this. It's now up to you, but even this one is now usable. So you say x pv pt, factor out x plus x, so now pt minus pv, right? So this is the formula. Okay, hope it's a nice formula for you to use, guys. So here I'll just brief you on how to use this formula, right? So you just, when you're given it, you postulate, because the type of values are not given, right? So you postulate. So let me just repeat what I said. This equation gives you the maximum value of x which you want to gain. Let's say we are told that your exit, let's say it's a gas absorption, and your exit here, maybe your gas enters here and exits here, right? So as you, maybe you're told y is 0.005, whatever. So now you change this into uppercase y by right, 0.05 over 1 minus what than 5, right? Then if you change this into this, you now plug it here. So because you're given pt and pv, you now plug it. So after plugging it, you now know the range, how your graph will be, because the maximum value of x you'll be knowing, right? So here, yes, you take your value of y from here, which is the largest value, of course. Fine, you will check it out. It will depend whether it's gas stripping or gas absorption, whatever. But the point, the biggest value of y is the one which you plug here, right? So that you know your highest value of x, right? So because your x values, you just postulate, you're not given any values, you just postulate according to how you want your curve to be. So it has to be limited by your highest value of y. So that's where this equation comes into play. Then now, if you've extrapolated your value of x, you now use this equation. You just have your x, your capital letter X, capital letter Y, just 0.02, 0.04, whatever. Then from this directly you just plug your values of fx here and your pt here, pv, then you just get your column directly. So but for you guys it's not too simple. You just need to memorize this formula. Okay, I would love if you call them the Terra formulas, but I know maybe some mathematicians have done that, but not in my watch. I've not seen that. But anyways, the thing is that you memorize these formulas. Right? We had memorized them with my friend after deriving these ones. So hope you have a good time. Remember to like and subscribe. Fine.